Integrated testing processes detect failure points earlier in the process lifecycle by using an approach that doesn't wait until the end of the product's lifecycle to begin the testing. For example, it's generally used in a software approach to testing whereby they take the entire device and test it at modular levels. If you look at an electronic device that has a camera, Bluetooth, and internet capabilities, the software developers will begin testing each one of those blocks rather than waiting until the end to see how they perform altogether. At AmeriCase, that can be shown by during the production process, we can determine how well the latches mate to the container, how well the base mates to the lid, and how well all the safety devices inside each of our containers will perform before we get all the way to the end of the product deliverable, where we have to test for thermal runaway containment or how the product will perform through all of the UN performance packaging steps. Vertical integration between engineering, testing, and production accelerates design validation and reduces risk by allowing every step in the process to deliver real-time data in the event of performance issues. For example, if there is a certain part coming from a vendor that we use in the construction of a case, we can test that part before waiting until we have the entire case built to determine if there's going to be a structural failure, and we can fix that redesign at step 1 rather than at step 12. So when we get to deliverable, we don't have to reinvent the wheel. The product is already identified all the potential flaws, and we deliver on time every time a successful product. Automation, real-time monitoring, and centralized data platforms strengthen resilience and traceability in testing operations in several ways. But first, let's define traceability. And traceability is essentially a documented journey of the product, and it identifies issues and allows for swift action if necessary, leading into resilience, which is your ability to adapt to any types of interruptions in the process and maintain operational stability. Automation allows for the system during production and testing to capture a potential flaw before a person has to go in and make the decision if there really is a flaw that's halting final production or not. Real-time monitoring does the same thing, where you don't have to wait until you get to the end of the process to do a quality control to identify if there's going to be a flaw that will cause the item to not be deliverable at the end of production during testing. And the centralized data platform allows everybody involved in the process to have access to that data from start to finish the product lifecycle, from concept to reality to a deliverable final product. The measurable ROI from resilient data-driven test labs compared to financial and reputational costs of a recall are identified essentially from not having bad PR, and then the financial cost of recovery of all your products that have already been delivered to end item users. So up front, it may seem quite expensive to use a resilient and data-driven test lab, but you're going to get all the flaws before you put that product to market. Once that product goes to market, it starts to be judged by everyone. It's going to be by the Better Business Bureau, by consumers themselves, and anyone who has any skin in the game as far as competition. How can they do it better? And one thing you don't want is having a recall where now you've got the marketability for your competitors to say, you see, I told you so, come and use ours. So it's the ROI is almost infinite if you don't have to suffer the repercussions of a recall.